and we have given examples on R. We have given examples on a set of all real numbers, right? And we extend that idea to R power n. Suppose, let us start with x equals to R square, set of all order pairs. So suppose you start with this. Suppose let us take x is equals to x1, x2, y equals to y1, y2, which are the elements of R2. So my definition is x1 minus 2y1. The question is it a metric on R2 or not? The answer, to answer this question, there is no problem with non-negativity because here it is modulus is there. So d1 of x comma y should be non-negative. There is no problem with this. What is the second property? Distance is 0. What is the definition? Mod of x minus 2y1 is equal to 0. But mod is 0 if and only if x minus 2y1 is equals to 0. That is equals to if and only if x is equals to 2y1. But which is not same as, which is not exactly equals to y1. Right? Which is not exactly equals to, of course, in fact, which is not exactly equals to y1, which is not x2 not equals to, may not be equals to, not equals to y1. I don't know whether x2 equals to y2 or not. I don't know about this information. No information about this. I don't know about this. So we can easily conclude this is my guess. Now we can give a counter. This is my guess. Right? So suppose I am going to take what I do. Suppose x is equals to 1, 0. Y is equals to, right? Or 2, you can take 2. This is 1, 0. Right? So therefore what happens? x1 is equals to 2y1. So satisfies. x1 is equal, this is x1, this is y1. x1 is equals to 2y1. Here, so clearly x not equals to y. But what about the distance? Distance between x and y is equals to modulus of x1 minus 2 into y1. That means 2 minus 2. That means 0. Therefore, distance is 0, but the points are different. Therefore, it cannot be a metric. So first you need to guess it, then you solve it. Suppose you can take this idea, d2 is equals to x comma y. This, only this, x1 minus y1. Is it a metric? What is my x? X is same, x1 comma x2, y is equals to y1 comma y2. So again, there is no problem with non-negative because modulus is there. The problem with only second condition and triangle inequality. So what is this? Actually, this is 0 if and only if mod of x1 minus y1 is 0. That means x1 minus y1 is 0. That means x1 is equals to y1. That means I don't know information about x2, y2. Yes or no? I don't know information about x2, y2. Now what I do is that I can take x is equals to 1 comma 0 or 1 comma 2. Right? 1 comma 0, nothing else. మీరు ఇక్కడ ఏది తీసుకున్న పని చేస్తాయి ఎందుకంటే మీ ఇష్టం అనేది రాసుకోవచ్చు. Right? Y is equals to 1 comma something 2. So x1 is equals to 1, 1 is here. So clearly x not equals to y. But what about x2? Distance between x2 comma y? So that is same as saying that modulus of x1 minus y1. That is equals to 0. So distance 0, but the points are different. Right? Therefore it cannot be a metric. Suppose d3 of x comma y is equals to mod of x1 minus y1 plus x2 minus y2. Is it a metric? So this is x is equals to what is the same? x1 comma x2, y is equals to y1 comma y2. Right? So same thing, distance is always non-negative because mod is there. Distance is non-negative. And distance is 0, second condition. The default only. This is x1 minus y1, 2 minus y2. So The thing is actually sum of this is non-negative, this is non-negative. Sum of two non-negative numbers equals to 0 if and only if each member is 0. Each member is 0. So modulus is 0, each of the term is 0. That is exactly equals to x1 is equals to y1 and x2 is equals to y2. That is x1 is equals to x1 is equals to y1, x2 equals to y2 means what? X equals to y. Right? This is a redundant idea, so it satisfies second property. And D3 is always symmetric because modulus is there, very strong condition. Is x1 minus y1 plus x2 minus y2. Right? So therefore, that is equals to y1 minus x1 plus y2 minus x2. Because modulus is there, mod of x is equals to mod of minus x. Is exactly same as saying the distance between y comma x. So distance satisfies symmetric property. Distance satisfies symmetric property. Right? What about triangle inequality? How many points do I require for triangle inequality? 3 points. So this is exactly what? X1 minus y1 plus x2 minus y2. Again using concat technique, adding and subtracting. Concat technique. So use this modulus of the sum less than or equals to sum of modulus by triangle inequality in real numbers. Right, just join this and this. Join this and this. Is exactly D3 of comma y. Therefore, it satisfies triangle inequality. Therefore, it is a metric. So D3 is a metric. This is called as L1 metric. On R2. Understand this? This is a metric. We can call this metric as L1 metric. So very standard metric actually. In fact, every metric is very, very important because I'm going to read again and again this metric properties in different orientations, different definitions, like open set, closed set. Right? Keep in this. So fourth one. D4 of x comma y is equals to maximum of mod of x1 minus y1, x2 minus y. So this also metric, you can easily check it by the same strategy. Right? Distance is non-negative because this is non-negative, this is non-negative. Therefore, distance between x comma y is non-negative and it satisfies second property. Distance between x comma y equals to 0 if only if x equals to the same idea. And distance satisfies symmetric property. Right? So we need to know the triangle inequality. That is important. For this, I can take two elements. Right? So I'm going to start with x1 minus y1. What is this? X1 minus z1 plus z1 minus y1. But this is exactly same as saying that x1 minus z1 plus z1 minus y1. But this exactly does not equals to maximum of x1 minus z1 comma x2 minus z2 plus this term less than or equals to maximum of z1 minus y1, right? X1 minus z1. All right. Sorry, x2 minus z2. What is this? This is exactly, you can write this as one term, keep it as it is. This is exactly z2 minus, right? right? So this is exactly what actually is exactly what distance between x comma z. This is nothing but distance under here for distance d4 of z comma y. Therefore, this term is less than or equals to this. Similarly, one can prove it. Distance between, see, if I consider this term, I'm going to get this. If you consider this term, the same one, less than or equals to this x comma z comma. So by using this, right, by using this for the set, which is it? For the set x1, y1, x2 minus y2. For the set, this is an upper bound. Which one is an upper bound? This one is an upper bound. For the set, which this one is an upper bound. Therefore, upper bound is a great, once it is an upper bound for the set, so this set has a greatest upper bound, greatest lower, greatest no. What is that? Least upper bound. Because it's an upper bound for the set, it has a least upper bound. That is what actually is supremum. Therefore, the supremum, which is a finite set, supremum has a maximum. Because it's a finite set, that supremum has a maximum. Therefore, this maximum is always less than or equals to this. Is it clear? This is an upper bound over there. Therefore, it has an infimum. Infimum means infimum among upper bounds, least upper bound. Therefore, that least upper bound for the finite set. Finite set is compact. Therefore, automatically it has a maximum. But what is this exactly? D of x comma y. Therefore, it satisfies triangle inequality, right? Hence, it is a metric. So this metric is known as L infinity metric. This is called as L infinity metric. Okay. Similarly, you can check. Fifth one. This is also standard metric. Distance between 2 points. Suppose you have a point here, x1, x2. This is my point y1, y2. This Euclidean distance. Under root of x1 minus y1 whole square, y2 minus x2 minus y2 whole square. I equals to 1 to 1. Y equals to 1 to 2. x1 minus yi modulus whole square. Whole square whole power 1 by 2. For x equals to this, y equals to this. So this is also metric. You can easily check it. It is always symmetric, right? So distance always non-negative. You can check these properties. This is modulus is there. The distance is 0 if only if the points are same. And distance satisfies symmetric property because modulus is there. You can. So what about triangle inequality? See, this is by Minkowski inequality. When you go through the function analysis, you know it. What is this? Summation I equals to 1 to 2 xi minus yi whole square whole power 1 by 2. Again, adding and subtracting technique. This is nothing but I equals to 1 to 2 xi minus zi plus zi minus yi whole square whole power 1 by 2. So just keep in mind, this is my Minkowski inequality in R power n. In R power n. Summation I equals to 1 to 1 xi yi whole power p whole power 1 by p less than or equals to summation I equals to 1 to n xi whole power p 1 by p summation I equals to 1 to 1 modulus of this whole power 1 by p, where x is equals to x1, x2, xn, y is equals to y1, y2, yn. Sequence of scalars or sequence of real numbers, you can take anything. And p is a number which lies between 1 to infinity, where P is a number which lies between 1 to infinity. So whenever is there, your P equals to 2, bigger than 1, therefore satisfy this. So this is a number, this is a number. By means cos inequality, summation I equals to 1 to 2 xi minus zi whole power P. P means 2 whole square whole power 1 by 2 plus summation I equals to 1 to 2 zi minus yi whole square whole power 1 by 2. This is exactly what d phi of x comma z plus z comma y. So hence it satisfies triangle inequality, hence it is a metric. This is exactly what Euclidean metric or usual metric. Metric on R2. This metric is what? Actually usual metric or standard metric or Euclidean metric, because Euclidean distance is there. On R2. Similarly, you can extend the idea to R power n also. Right? So this is about R power 2. You can extend this idea to R power n. Same. Okay, I'm not going to tell this R power n. You can extend this idea to. See what I'm doing. We are first reading. We studied about R. Then we extend this idea to R power 2. Similarly, we can extend this idea to sequences. Right? Problem number what? This is problem number 1. Next, I'm going to tell you problem number 2. You can extend this idea to sequences. Suppose 1 less than or equals to p less than infinity. Suppose my LP is in the sequence or space of all sequences which are p to summable sequences. Xi, this convergent series. Set of all sequences in such a way that which are p to summable sequences. In fact, you need, so in order to understand this idea in clearly, what you know is that suppose p, if you take p equals to 1, what happens? This is what L1. L1 is nothing but what? Set of all sequences, 1 to summable sequences. That means what? Set of all sequences. This is convergent series. Means what? The sequence is absolutely convergent. Understand what is this? Set of all absolutely convergent, because modulus of xi is convergent. Set of all absolutely convergent sequences. Suppose you take this. Is it absolutely convergent sequence? Yes, because by p-test it is convergent. Suppose I'm going to take 1 by 2 square, 1 by 3 square. This is my sequence. Is it absolutely convergent? Yes. Summation x I equals to 1 to infinity, xi is nothing but summation I equals to 1 to infinity. What is xi? 1 by I square modulus. But I square is always positive. No need to take modulus. This is by p-test is convergent. So this is absolutely convergent. Hence it is an element of L1. Understand? So this is my L1. Similarly, you can extend this idea to for p equals to 2. So set of all square summable sequences. Square summable sequences. So can you give an element? Yes, I can give an element. What is that? I can take like 1 by n. See, in this case, suppose I am going to take x is equals to 1 by 2, 1 by 3 like this. Is it an element of L1? No. Understand? Why? Because I equals to 1 to infinity. Mod of xi is nothing but what? Summation I equals to 1 to infinity. Mod of 1 by I is nothing but summation I equals to 1 to infinity 1 by I. You know, by p-test it is divergent. Understand? It's not convergent. Right? Therefore, this x should not be a member of L1. Set of all 1 by n means what? 1, 1 by 2, 1 by 3, 1 by 4, 1 by 5 is a sequence, but which is not an element of L1. Whereas set of all sequence, that the sequence of real numbers 1, 1 square, 1 by 2 square, 1 by 3 square, 1 by 4 like that is always an element of L1. See here, suppose you take this x is equals to 1, 1 by 2, the same sequence. Is it an element of L2? Yes, because it's an element of L2. Why? Because actually, look at this definition. summation I equals to 1 to infinity modulus of xi whole square is exactly summation I equals to 1 to infinity. Xi means 1 by I square. This is a typical term. By p test it is convergent. Hence it's an element of L2. So this is a definition of LP spaces. Right? This is a definition of LP spaces. Right? So the same strategy d of d1 of x comma y is equals to summation I equals to into infinity modulus of xi minus y. నేను ప్రూవ్ చేస్తలేను సేమ్ స్ట్రాటజీ బై మీన్స్ కాస్ ఇన్ఈక్వాలిటీ. సో దిస్ ఇస్ ఆల్సో మెట్రిక్ we have seen, right? Euclidean metric అని చెప్పి ఇంత ముందు 2 whole power 2, right? For x is equals to x1 x2 same strategy LP where p 1 less than or equals to p less than infinity. So this is a metric on LP, right? D2 nothing but 1 x comma y is equals to maximum, not maximum, supremum, because there are infinite many terms, we don't have enough maximum. Supremum of mod of xi minus y, where I belongs to it. This also metric. ఇంతకుముందు చదివాం కదా మాక్సిమం ఆఫ్, ఇక్కడ చదివాం గుర్తుంది కదా, సేమ్ ప్రూఫ్ నేను చేయట్లేనండి, సేమ్ ప్రూఫ్ ఇక్కడ చేసాను చూడండి. సుప్రీమం ఇక్కడ మ్యాక్సిమం తీసుకున్నాను, ఇక్కడ ఏం తీసుకున్నాను, సుప్రీమం తీసుకున్నాను, సేమ్ ప్రూఫ్ నేను చేయట్లేను. దెర్ఫోర్ దిస్ మెట్రిక్ which are metrics on LP spaces. Okay, so this is about LP, right? See, we are taking the element, ఇక్కడ చూడండి అమ్మా, we are taking p is an element lies between 1 to infinity. Why don't you take p from 0 to 1? Why don't you take p negative? Why don't you take p negative? This is the definition. This is a definition. Suppose you take the LP space ఇట్లా తీసుకొని ఇట్లా తీసుకోవచ్చా, p less than 1. Suppose distance between x and y is equals to summation I equals to 1 to infinity mod of xi minus y whole power p whole power 1 by p అని తీసుకోవచ్చా? ఇది మెట్రిక్ అవుతుందా ఆన్ ఎల్పి మీద? ఇది అవుతుందమ్మా, ఇది మెట్రిక్ అవుతుందా? సో ఇది p లైస్ బిట్వీన్ 0 to 1 ఉన్నప్పుడు కాదు, ఎందుకంటే యాక్చువల్గా మీరు x is equals to 1 తీసుకోండి, 1 0 0 0 0 0 0, లేకపోతే ఇన్ఫాక్ట్ ఆర్ పవర్ అనేది తీసుకోండి, ఇదంతా అవసరం కూడా లేదు, ఆర్ పవర్ n తీసుకోండి. ఆర్ పవర్ n లో ఎలిమెంట్స్ ఏమొస్తుంది, n టపుల్స్. అప్పుడు ఏమైతే మెట్రిక్ చెప్పాను కదా, ఎన్కి ఎక్స్టెండ్ చేయొచ్చు అని. సో 0 y నేమ్ తీసుకోండి, 0 1 0 0 0 0 0. z నేమ్ తీసుకోండి, మీ ఇష్టం, 0 0 0 0 0. ఒక్కటి ఫెయిల్ అయితే చాలు. సో మీరు అబ్జర్వ్ చేస్తే డిస్టెన్స్ బిట్వీన్ ఎక్స్ అండ్ వై ఏమొస్తుంది, సమ్మేషన్ y ఈక్వల్స్ టు యూక్లిడియన్ డిస్టెన్స్ అండి, యూక్లిడియన్ డిస్టెన్స్. వాట్ ఈస్ దిస్ యూక్లిడియన్ డిస్టెన్స్? అండర్ రూట్ ఆఫ్ x1 minus y1 whole square, the formula. So 1 minus 0 whole square, 0 minus 1 whole square, right? Individual right? No need to write in sum. So 0 minus 1 whole square plus 0 minus 0 whole square, like this. 0 minus 0 whole square whole power 1 by 2. But what is this? 1 plus 1, 2, 2 power 1 by 2. Right? This is D. Similarly, distance between x comma z ఎంత అవుతుందండి? This is nothing but distance between x comma z. What is this? 1 minus 0 whole square going on 0 minus 0 whole square whole power 1 by. This is exactly what? 1. This is exactly same as saying the distance between z comma y also. So what you observe, triangle inequality satisfy చేయాలి కదా, ఇది satisfy చేస్తా. ఇది యాక్చువల్ ఏంటి, లెఫ్ట్ సైడ్ రైట్ సైడ్ ఏంటి, ఇది 1 plus 1 అంటే ఏంటి, 2. 2 is always bigger, you know, 2 is always, what is this? సో నేను 2 తీసుకున్నానా, సారీ ఇక్కడ p తీసుకోవాలి కదా, రైట్, p తీసుకోవాలి కదా, చూస్తలేం కదా, అందుకే ఇక్కడ సాటిస్ఫై చేస్తలేం, p కదా, మనం p తీసుకోవాలి, p గురించి మాట్లాడుతున్నా కదా. సో దిస్ ఇస్ ఎగ్జాక్ట్లీ వాట్, p. ఎట్లా తీసుకున్నా సేమ్ స్టోరీ. అండ్ ద థింగ్ ఈస్ దిస్ ఇస్ 2 power 1 by p. This is p. This is p. This is 1. ఇక్కడ చేంజ్ కాదు. ఇది 2 power 1 by p. So 2 bigger than 2 power 1 by p. Why? Because p lies between 0 to 1 కాబట్టి 1 by p bigger than 1 అవుతుంది కాబట్టి అసలు p lies between 0 to 1 ఆల్రెడీ ఇచ్చాను కాబట్టి 1 by p ఏమైంది bigger than 1. Therefore 2 power 1 by p is always bigger than 2 power 1. That is exactly 2. Therefore triangle inequality fail అయిపోతుంది కదా. So it cannot be met కదా. That is not a metric. Not for n. మీరు ఎల్ ఇన్ఫినిటీ కూడా మీరు ఎల్పి స్పేసెస్ కూడా ఎక్స్టెండ్ చేయొచ్చు. ఓకే, మీ ఎల్పి స్పేసెస్ కూడా ఇదే విధాన్ని ఎక్స్టెండ్ చేసుకుండవచ్చు. సో మనం ఏం చేసాం, ఫస్ట్ R2 తర్వాత సీక్వెన్సెస్ గురించి వచ్చాం. సో నెక్స్ట్ ఏంటి, సీక్వెన్సెస్ తర్వాత సీక్వెన్సెస్ లో చాలా ఉంటాయి, ఎల్పి ఉంటాయి, C0 ఉంటాయి, సి ఉంటాయి, ఇవన్నీ ఉంటాయి. బట్ జస్ట్ రాయిస్తున్నాను ఇక్కడ, జస్ట్ థర్డ్ ఎగ్జామ్ ఎల్ ఇన్ఫినిటీ. L infinity means space of all bounded sequences. Proof as it is means it's a bounded sequence. Right? So bounded sequence means, so suppose you take this, x is equals to 1, 2, 3, 4 going on. Is it an element of L infinity? No, because it's not a bounded sequence. It's not a member of L infinity. Suppose you take x is equals to 1, 1 by 2, 1 by 3 going on. Is it a bounded sequence? Yes. Is it a bounded sequence? Yes. Lower bound is this, upper bound is this. Therefore, it's a bounded sequence. Right? So, can you give a metric? Yes. D of x comma y is equals to. So, bounded means always supremum exists. Therefore, you can take the supremum of xi minus yi. I belongs to. For you can take any bounded sequence, two bounded sequence. So, this is a metric by the same proof. Okay, already metric in definition ఆటోలో ఇచ్చాను, సేమ్ ప్రూఫ్ యాజ్ ఇట్ ఈస్ ప్రూఫ్. మాక్సిమం ప్లేస్ లో సుప్రీమం వస్తుంది అంతే. ఓకే, దిస్ ఇస్ అబ్వియస్లీ మెట్రిక్ ఆన్ దట్. సో C0, C0 ఇవన్నీ ఉంటాయి. C set of all convergent sequences. This is convergency. So convergent sequence లో కూడా యాక్చువల్గా suppose you take this, is it an element of, suppose you take this 1 square, 2 square, like this 3 square, is it an element of C? No, because it's not a convergent, it's not in fact bounded, therefore it's not convergent, it's not an element of C. Suppose you take this 1 by 1 square, 2 square, 1 by 2 square going on, 1 by 3 square going on, 1 by n square in fact, so it converges to 0, therefore it is an element of C. Why? Because 1 by n square tends to 0 as n tends to is a convergent sequence. So can you give me a metric? So every convergent sequence is always bounded, therefore you can give a metric on C as a supremum metric. Right? So next same idea, C0. C0 means space of all sequences which converges to 0 sequence. Set of space of all sequences which converges to 0. So this is also space, the same metric workout type metric చేసుకోవచ్చు. Right? So this is about sequences. This is about sequences. Right? So interesting కదా. R square, R power n. Next sequences. Next ఏంటి, next sixth example number, yeah, 6th sequences లోనే కొంచెం different sequences ఉంటాయి, you should be very careful. X is equals to space of set of all real sequences So metric, what is a metric is, this is very standard metric, summation I equals to 1 to infinity. You can take any convergent member, means what, this is 1 by 2 power I mod of xi minus yi divided by 1 plus, yesterday a problem, the orientation problem, x is equals to x1 x2 going on, y equals to y1 y2 going on. You know, first is the meaningful sum. Yes, because meaningful sum. Why meaningful sum? This term is always less than 1 plus 1, less than or equals to 1 plus this. This is positive term because this is non-negative, this is positive. Non-negative plus positive is always positive. Therefore, mod of x minus I by 1 plus is less than or equals to 1. This is true for every I. Now multiply with 2 power I. This is positive real number. The inequality doesn't change. So by comparison test, you know, this is convergent. As you know that this is convergent. So obviously implies that this is convergent. Two power I 1 plus mod of xi minus yi is convergent. But this is exactly what? This is exactly distance between x and y. So this function is well defined. This function is well defined. So remaining properties are as usual. There is no problem as it is. As it is proof finally. So as it is proof. Therefore this is a metric. It is a metric. On x. Right? Space of all. See, 2 పెట్టింది. Why don't you take different numbers అంటే మీరు different numbers కూడా తీసుకోవచ్చు. Understand? Suppose ఇది 1 అని తీసుకో. ఇది కూడా మెట్రిక్, రైట్? సో కన్వర్జెంట్ కు ప్రాబ్లం లేకుండా ఏ మెంబర్ అని ఇవ్వండి, నథింగ్ రాంగ్. 1/3 1/4 1/5 మీరు ఏదన్నా ఇవ్వండి, రైట్? కన్వర్జెంట్ కు ప్రాబ్లం లేకుండా మీ ఇష్టమైన నెంబర్ ఇవ్వండి, సరిపోతుంది. 1/n² అది కూడా కన్వర్జెంటే కదా. ఇదే ఎగ్జాంపుల్ నేను ఇట్లా ఇచ్చింది అనుకోండి, ఇట్లా ఇద్దాం మరి. సరే ఇట్లా తీసుకోవచ్చా? ఇట్లా తీసుకోవచ్చా? సపోజ్ నేను ఇట్లా ఇస్తా 1/2² 1/3² గోయింగ్ ఆన్. ఓకే, ఇట్లా ఇస్తా. లేదా ఇట్లా ఇట్లా వేయకండి. యూ కెన్ టేక్ 1 2 3 4 గోయింగ్ ఆన్. 1 0 0 లేకపోతే 1 1 1 1 1 ఇచ్చినా పర్లేదు. ఏమి ఇస్తారు? 1, ఇది 1 వచ్చేటట్టు చూడండి. ఇది 0 ఇస్తే ఏమొస్తుంది? 1/2 వస్తుందా? ఇక ఇష్టం, చూద్దాం ఏమైతే. 0 y is equals to 0 0 0 0 0 సీక్వెన్స్. రియల్ సీక్వెన్స్ అయితే చాలు. వాట్ ఈస్ మై ఎక్స్? సెట్ ఆఫ్ ఆల్ రియల్ సీక్వెన్స్. మీ ఇష్టమైన సీక్వెన్స్ తీసుకోండి. అది కన్వర్జెంటా డైవర్జెంటా నేను ఏం చెప్పలేదు. జస్ట్ సీక్వెన్సెస్, స్పేస్ ఆఫ్ ఆల్ సీక్వెన్స్, రియల్ సీక్వెన్సెస్. వాట్ అబౌట్ డిస్టెన్స్? వాట్ అబౌట్ డిస్టెన్స్? xi minus yi. వాట్ ఈస్ దిస్? xi minus y అంటే ఏమొస్తామా? 1 minus 0. What you get is by 1 plus 1 minus 0. That is exactly what? 1/2. Right? 1/2. 1 minus xi minus yi by 1 plus xi minus yi. కదా? మిగతా టర్మ్స్ ఏమైతాయి? జీరోస్. మిగతా టర్మ్స్ ఏమైతాయి? దిస్ ప్లస్ 0 minus 0 by 1 plus 0 minus 0 plus 1 plus 0 minus 0 1 plus 0 minus 0 ఇవన్నీ ఇట్లా వచ్చేస్తాయి. బట్ మీకు ఇక్కడ సర్వైవ్ అయ్యేది ఏంది? ఓన్లీ ఈ టర్మే 1 plus 1/2 కదా. సర్వైవ్ టైం ఏంటి? ఓన్లీ ఈ టర్మే. బట్ ద థింగ్ ఈస్, ఈ సిరీస్ కన్వర్జెంట్ అవుతుందా? ఈ సిరీస్ కన్వర్జెంట్ అవుతుందా? ఇట్స్ నాట్ కన్వర్జెంట్ బై సేమ్ ఆర్గ్యుమెంట్. ఇట్స్ నాట్ కన్వర్జెంట్. సో కాబట్టి దిస్ ఇస్ ఇన్ఫాక్ట్ దిస్ ఇస్ నాట్ ఏ కన్వర్జెంట్ సిరీస్. సో నాట్ కన్వర్జెంట్ సిరీస్ కాబట్టి ఆటోమేటిక్ ఏమైంది? ఇట్స్ నాట్ ఏ వెల్ డిఫైన్ ఫంక్షన్. నేను ఏమని చెప్పాను? ఇఫ్ దెర్ ఈస్ ఎ ఫంక్షన్ సాటిస్ఫైడ్ ద 4 ప్రాపర్టీస్, ఫస్ట్ ఫంక్షన్ కావాలి. ఈ సిరీసే కన్వర్జెంట్ కాలేదు. ఈ సిరీస్ కన్వర్జెంట్ కాదు కాబట్టి ఇట్స్ నాట్ ఎ వెల్ డిఫైన్ ఫంక్షన్. హెన్స్ ఇట్ ఇస్ నాట్ ఎ మెట్రిక్. అండర్స్టాండ్. సో కన్వర్జెంట్ కి ప్రాబ్లం లేకుండా ఫస్ట్ ఇది ఫంక్షన్ అయి ఉండాలి. డి అనేది ఫంక్షన్ అయి ఉండాలి. ఉన్నప్పుడు మాత్రమే 4 ప్రాపర్టీస్ చెక్ చేయాలి. డి ఫంక్షనే కానప్పుడు సో వీ డోంట్ వాంట్ టు చెక్ ఆల్ హోల్ ప్రాపర్టీస్ ఆఫ్ ద డి, రైట్? ఇట్స్ నాట్ ఏ కన్వర్జెన్స్ బేస్డ్. మీరు ఇక్కడ ఇంకోటి కూడా చేయొచ్చు. సో ఇంకోటి ఏం చేయొచ్చు, సపోజ్ నేను ఇట్లా ఇచ్చాను అనుకోండి, సార్ సరిపోతులే, నేను ఒకటి ఇస్తే చాలే, right? So this is about sequences. This is about sequences. Next to functional spaces. Next is what? This is 7th. Functional spaces means space of all continuous functions, space of all bounded functions, a real world function which is bounded. So can you give a metric? Yes. In fact, maximum attains because any bounded function on this as the maximum. In fact, supremum తీసుకున్న problem లేదు. Supremum of f of t minus g of t this for any two functions. This is also metric by the same proof. Okay, same proof. నేను r power n కు maximum పెట్టి చేశాను కదా, సేమ్ అదే లైన్స్ అదే యాజ్ ఇట్ ఈస్ గా రాయండి. therefore this is also metric. Right? This is first example. Second one, continuous functions. Continuous function. So what is the metric? Same metric. See this, any continuous function on this attains maximum, therefore you can take max. Right? This is also metric by the same proof.
Sir.
Right?
Sir, one can ask the question, minimum is also metric?
No, sir, no. Minimum may not be metric. Suppose you take this.
Okay. Standard.
Infimum of this. At t lies between 0 to 1. Okay? Infimum is here అనుకోండి. Suppose నేను f is equals to t ఇస్తాం. Right? G is equals to 0 ఇస్తాం. 0 function. They are continuous functions. No problem. Right? So what about the distance? Distance between f comma z is equals to infimum of f of t is nothing but t minus 0 where t belongs to close 0 1. Therefore this is infimum of mod of t where t belongs to close 0 1. What is infimum of mod of t? 0, right? Right? It is 0. So distance is 0, but the two functions are not same. They are different at one point. Therefore f not equals to 0. Why? Because f of 1 is equals to 1, f of 1 is equals to 0. So both are different at one point, single point. Therefore they are not equal functions. So infimum may not be a metric. Right? This is about continuous functions. Right? This is bounded functions. Right? So this is about spaces. Space of all functions, functional spaces. ఎంతమంది చదివింది? సీక్వెన్స్ స్పేసెస్. అంతమంది చదివింది ఆర్ పవర్ ఎన్, అంతమంది చదివింది ఆర్. ఓకే, నెక్స్ట్ ఈస్ algebra matrix. Right? First question before going to this. Yeah, okay. First one. Suppose D1, D2 matrix. On a set X. Does it mean that sum of two matrix is again a metric? So to answer this question, the idea is very trivial. You can take this as D. is equals to d1 plus d2. See, ఇది చాలా ఇంపార్టెంట్. చూడడానికి సింపుల్ నోట్ లాగా కనబడుతుంది కానీ దీన్ని యూజ్ చేసి గేట్లో సిఎస్ఆర్ క్వశ్చన్స్ వచ్చినాయి. ఓకే, చూడడానికి సింపుల్గా ఏదో నోట్ లాగా కనబడుతుంది కానీ యాక్చువల్గా ఇది చాలా ఇంపార్టెంట్. సో ఫస్ట్ వన్ ఈజ్ వెరీ ట్రివియల్ కదా. ఫస్ట్ 3 ప్రాపర్టీస్ ఆర్ వెరీ ట్రివియల్. ఎందుకు? డిస్టెన్స్ బిట్వీన్ x and y ఈజ్ ఈక్వల్స్ టు d1, x, y plus d2 of x, y. You know, d1 metric, d2 metric, but automatically non-negative. Sum of non-negative is always non-negative. Kada? And distance is 0 if and only d1 of x, y plus d2 of x, y is 0. Right? But this is non-negative. Sum of non-negative is 0 if and only if each individual term is 0. This is exactly x is equal, because d1 is a metric, therefore x equals to y. And it satisfies symmetric property. These are redundant. మీరు ప్రూవ్ ఇది ఎగ్జామ్లో ఇవన్నీ చేయాల్సిన అవసరం లేదు. ఎందుకు? ఇవన్నీ మెట్రిక్ అయితే కదా, d1 d2 మెట్రిక్ కాబట్టి ఆటోమేటిక్గా ఇది చేయాల్సిన అవసరం లేదు, మీకు తెలిసిపోతుంటారు. సో థింగ్ ఏంటంటే ట్రయాంగిల్ ఇన్ఈక్వాలిటీ ఒకటి చెక్ చేయండి. d of x, y that is equals to d1 of x, y plus d2 of x, y. But d1 is a metric, therefore it can be written as d1 of x, z, z, y plus d2 of x, y, z, because d2 is a metric, z, y. Right? So we can join this and this. Plus d1 of z, y, join this and this. This is d1 of d of x, z by definition. This is d of z, y. So it satisfies triangle in. Hence it is a metric. So what do you conclude? Sum of metric is always a metric. Sum of metric is always a metric. Right? What about difference? Does it mean that difference d1 minus d2 metric on x? To answer this question, it need not be. Example, suppose I am going to take d1 of x, y is equals to mod of x minus y. You know, it's a standard metric on R, on x equals to R. It's a metric on R. We have seen first example, right? I'm going to take 2 distance between x, y is equals to 2 into mod of x, y. This is also standard metric on R. We have seen it. So therefore, what about d1 minus d2? d1 minus d2 is equals to what is this? Mod of x minus y minus 2 into mod of x minus y is nothing but minus of mod of x minus y. But whenever it is metric d1 minus d2, it should not be negative. It should be positive, non-negative in fact. So this is actually what? Less than or equal to 0. So it cannot be metric. Understand? Suppose I'm going to take x is equals to 2, y equals to 1. Both are real numbers. This, suppose you take this is my d. So distance between x, y, what is this? Minus of mod of 2 minus 1, that is equals to minus of 1. This is less than 0. Therefore, it cannot be metric. So difference of two metrics may not be metric. What about multiplication? Product of metrics. Right? Is it a metric? So in general, need not be again.
Respond in chart box. ఎవరు రెస్పాండ్ చేస్తలేరండి, ఇంత ఎర్లీ మార్నింగ్ క్లాస్ చెప్పిస్తున్నాము.
Okay. Suppose you take this d1 of x, y standard metric. d2 of x, y also same. Take this. X, y are the real numbers. You take the product. So clearly d1, d2 are metrics, no doubt. So d1 into d2 is exactly what? Mod of x minus y into mod of x minus y. This is whole square. So question is it a metric or not? Suppose you can take this is d. Question is it a metric or not? D is a metric or not? Means there is no problem with non-negative because square is there. X square is always non-negative above x axis. Non-negative is there. and distance between x and y is 0 if and only if x minus y whole square is equals to 0. That means x square 0 if and only if x 0, that is if and only if x equals to 1. So there is no problem with the symmetric property because square is there. So clearly x square is equals to minus of x square, therefore satisfies symmetry property. So the problem with only triangle inequality, suppose for that what I do is that I'm going to take 2 is x is equals to 2, y equals to minus 1. You can take actually z is equals to 0, right? So distance between x and y is equals to what? Mod of means mod of x minus y whole square. That means 2 minus minus of minus 1 whole square. That is exactly what? 3 square. That is exactly what? 9. Right? 1 తీసుకున్నా పర్లేదు ఇక్కడ ఇంకా సింపుల్ గా రావడానికి 1 తీసుకున్నా సరే చూద్దాంలేండి ఎట్లయితే. I don't know. X comma z. What is x comma z? X comma z is nothing but 2 minus 0 whole square. That is exactly what? 4. What is z comma y? Z minus y whole square. That means what? 0 minus of minus 1 whole square. That is exactly what? 1. Therefore, we observe that distance between x and y is equals to 9, but 9 is always bigger than 4 plus 1. Right? But 4 is nothing but distance between x and z. This is z comma y. Therefore, it fails to satisfy triangle inequality, hence it cannot be a metric. D1, D2 are matrix on x equals to r, but D1 into D2 may not be metric. Right? Next, what about square root of metric?
Hello, sir.
What about division? So division in general may not be metric because if you take, see, in fact, it's not meaningful. It's not metric.
Hello.
Why? Because D2 can be 0, yes or no? D2 can be 0. It's not a meaningful function, in fact. కదా ఇక్కడ D2 of x, x రాస్తే ఏమైంది? X, x రాస్తే ఏమైంది? 0 అవుతుంది కదా, denominator 0 వస్తుంది కాబట్టి it's not a well defined function. D1 by D2 is not a well defined function, hence it is not a metric. What about square root of a metric? Is it a metric? Next,
Respond please.
whenever D is a metric.
Yeah, respond on.
We know not to take more values for triangle inequality because it once that condition fails for at least 3 points, the result triangle inequality cannot be true. మనం ఫెయిల్ కావాలంటే అట్లీస్ట్ 3 పాయింట్స్ చాలు, అన్నీ చెక్ చేయాల్సిన అవసరం లేదు. Right. So suppose you take this delta of x comma y is equals to root of d of x comma y for x comma y belongs to x. So non-negativity problem లేదు because root is always non-negative కదా, non-negative problem లేదు. నెక్స్ట్ ఇది కూడా ప్రాబ్లం లేదు because d is a metric కాబట్టి. So that is d of x comma y 0. That is if and only x equals to y because d is a metric. Symmetric కూడా ప్రాబ్లం లేదు ఎందుకు d is a metric కాబట్టి. ఈ మూడింటికి ఎట్లాంటి ప్రాబ్లం లేదు. So problem with negative square triangle inequality, right? So for that what I do is that we take this. So square root ఉంటే కొంచెం హ్యాండిల్ చేయడం కష్టం అవుతుంది కాబట్టి స్టార్ట్ విత్ దిస్. ఇక్కడే స్క్వేర్ తీసి పడేసేయండి. స్క్వేర్ వేసి ఇదే వస్తుంది కదా. బట్ వాట్ ఈస్ ద ట్రయాంగిల్ ఇన్ఈక్వాలిటీ? బికాస్ d is a metric, d satisfies triangle inequality. దీన్ని ఇట్లా రాయొచ్చు కదా, రైట్? దీన్ని ఇట్లా రాయొచ్చు, రైట్? సో దిస్ ఆల్వేస్ లెస్ దెన్ ఆర్ ఈక్వల్స్ టు డిస్టెన్స్ బిట్వీన్ x comma z, z comma y. దీన్ని ఇట్లా రాయొచ్చా? x comma z ఇంటూ జెడ్ కామ వై. వై ఎందుకు రాయొచ్చు? ఇది నాన్ నెగిటివ్ టర్మ్ యాడ్ చేస్తాను, నథింగ్ రాంగ్ కదా. దీన్ని ఇట్లా రాయొచ్చు. Right? So this is non-negative. So non-negative, this square is delta square is less than or equals to, what is this? This is d of x comma z plus d of z comma y, this whole square. So take square roots on both sides because this is non-negative. Once take the square roots on both sides, what you get is this is for any three elements. So therefore this delta is a metric. So square root of a metric is always a metric, and no doubts. Example, you can take and more examples. You can take 20 of examples. Suppose you take this, d is equals to this mod of x minus. This is a standard example in Rudin. Even Rudin lo em తీసుకుంటాడు అంటే ఇట్లా తీసుకుంటాడు. సో therefore ఇది always a metric, because ఇది మెట్రిక్ అయినప్పుడు స్క్వేర్ రూట్ ఆఫ్ ఎ మెట్రిక్ కూడా మెట్రికే. ఇక మనం చెక్ చేయాల్సిన అవసరం లేదు కదా. ఇప్పుడు ఇట్లా తీసుకున్నారు అనుకోండి, ఫర్ ఎగ్జాంపుల్ d of x y is equals to, suppose టూ 2023 ఇయర్ పెట్టిస్తాడు ఏదో ఒకటి, 5 some mod of x minus y plus 5 for 2023 into square root of mod of x minus y. So question is it a metric on R అంటాడు. ఆల్వేస్ మెట్రిక్. ఎందుకు చెప్పండి, ఎస్టర్డే మీకు చెప్పాను, గుర్తుంది కదా. ఫస్ట్ ఇది మెట్రిక్, mod of x minus y and r, ఇది మెట్రిక్ అయితే ఇది మెట్రిక్ కదా, ఇది పాజిటివ్ టర్మ్. సో సమ్ ఆఫ్ మెట్రిక్ ఈజ్ అగైన్ మెట్రిక్ అని ఇప్పుడే చెప్పాను కదా. సో ఎస్టర్డే మీకు చెప్పాను, మినిమమ్ ఆఫ్ ఎనీ పాజిటివ్ రియల్ నెంబర్ సమ్ మెట్రిక్ ఈజ్ ఆల్వేస్ ఎ మెట్రిక్ అని గుర్తుంది కదా. మినిమమ్ ఆఫ్ సమ్ పాజిటివ్ రియల్ నెంబర్ కామా మెట్రిక్ ఈజ్ ఆల్వేస్ ఎ మెట్రిక్, ఈజ్ ఎ మెట్రిక్. సో కాబట్టి ఇది మెట్రిక్. ఇది గేట్లో వచ్చిన క్వశ్చన్, ఇది మోడల్. అర్థమైంది కదా. mod of x minus y మెట్రిక్ అవుతుంది. పాజిటివ్ మల్టిపుల్ ఆఫ్ మెట్రిక్ ఈజ్ ఆల్వేస్ ఎ మెట్రిక్. సో ఇది మెట్రిక్, ఇది మెట్రిక్. ఇప్పుడు ఇంత ఉంది కదా, స్క్వేర్ రూట్ ఆఫ్ mod of x minus y మెట్రిక్. సో సమ్ ఆఫ్ మెట్రిక్ ఈజ్ అగైన్ ఎ మెట్రిక్. సో yeah, this is a metric. So positive term comma this metric minimum always a metric. Right? సో ఇట్లాంటి ప్రాబ్లమ్స్ మనకి ఎక్కువ ఫోర్స్ చేయడానికి వీలు ఉంటుంది అనమాట. సో ఇదే ప్రాబ్లం ఇట్లా కూడా చేయొచ్చు. మినిమమ్ ఆఫ్ 100,000 comma mod of x minus y by 2023 plus mod of x minus y. Is it a metric? 100. Yes, we have seen it yesterday. This is a metric. So automatically this total is a metric. ఇంకో క్వశ్చన్స్ ఎట్లా అడుగుతారు అంటే, డస్ దేర్ ఎగ్జిస్ట్ ఏ మెట్రిక్, డస్ దేర్ ఎగ్జిస్ట్ ఏ మెట్రిక్ on R, D metric on R such that whose distance less than or equals to 2300. ఇట్లా ఉంటుందా, అసలు పాసిబిలిటీ అవుతుందా అంటాడు. ఎస్, ఆల్వేస్ పాసిబుల్. సో ఒక మెట్రిక్ ఇట్లా ఎగ్జిస్ట్ అవుతుందా అంటాడు ఆల్వేస్. ఎట్లా ఎట్లా ఎట్లయితే చెప్పండి, మినిమం ఇట్స్ వెరీ స్టాండర్డ్, చెప్పాను కదా, చాలా యూస్ఫుల్ అని. మినిమం ఆఫ్ ఇట్లా ఇస్తే సరిపోతుంది కదా. సార్ ఇది మెట్రిక్, ఎస్టర్డే వి హావ్ సీన్. సో దిస్ మినిమం ఈజ్ ఆల్వేస్ లోవర్ బౌండ్ ఫర్ ద సెట్ కదా. సో దిస్ 2023 అని రాసుకోవచ్చు కదా, లెస్ దెన్ ఆర్ ఈక్వల్స్ టు 2023 అని రాసుకోవచ్చు కదా. సో దెర్ఫోర్ ఆల్వేస్ పాసిబుల్ అనమాట, ఈజ్ ఆల్వేస్ పాసిబుల్. ఓకే, సో ఇట్లా క్వశ్చన్స్ అడగొచ్చు. ఓకేనా? నెక్స్ట్ ఈస్ ఓపెన్ బాల్. ఇది చెప్దామా సార్? చెప్పాలా ఇది? హలో,
Continue, sir.
సో మెట్రిక్స్ కాన్సెప్ట్స్ హావ్ బీన్ హోవర్డ్. ఓకే, సో చూసుకోండి, మెట్రిక్స్ అన్ని సాల్వ్ చేసినాం ఆల్మోస్ట్, డిఫరెంట్ మోడల్స్. నెక్స్ట్ ఇస్ నైబర్హుడ్ ఆర్ ఓపెన్ బాల్. ఒక్కొక్క బుక్లో ఒక రకంగా అంటాడు. రూడిన్లో మాత్రం నైబర్హుడ్ అని యూజ్ చేస్తాడు, మీ ఇష్టం. Right, suppose you start with a metric space. Right, this is my metric space. Suppose you take a point in a metric space, you take some radius r positive. This suppose this is my r radius. So neighborhood of a point A with radius r denoted by like this. According to routing notion, neighborhood of A with radius r, or else you can take neighborhood of a point P with routing notion. Point P, neighborhood of a point P. So what is the definition is, for example, నేను R100 ఇచ్చాను అనుకోండి. సో what is the definition is, మెట్రిక్ స్పేస్ లో ఉన్న అన్ని పాయింట్స్, సపోజ్ ఈ పాయింట్ మీరు చెక్ చేశారు, ఈ పాయింట్ డిస్టెన్స్ అనుకుంటే ఆర్ కంటే తక్కువ ఉంది. ఈ పి కాంచి ఇది పి నుండి ఎక్స్ కి డిస్టెన్స్ ఆర్ కంటే తక్కువ ఉంది, కాబట్టి ఈ పాయింట్ నైబర్హుడ్ లో ఉంటాయి. సెట్ ఆఫ్ ఆల్ పాయింట్స్ ఇన్ ఎ మెట్రిక్ స్పేస్ whose distance from P should be less than R. Whose distance, that means what? Set of all these points in a metric space whose distance from P is always less than R. Right? Set of all points in a metric space whose distance from P is less than R. Right? This is what I said, a definition of a neighborhood of a point P. ఇది యాక్చువల్గా నేను ఓపెన్ బాల్ అని కూడా చదువుతాను, మీరు కన్ఫ్యూజ్ కావద్దు, ఎందుకంటే రెండు నొటేషన్స్ వాడతాను. దిస్ ఇస్ నథింగ్ బట్ ఓపెన్ బాల్ సెంటర్ ఎట్ P విత్ రేడియస్ R. బట్ రూడింగ్లో ఇవి రెండు డిఫరెంట్గా రాస్తాడు, బట్ అవసరం లేదు. ఓపెన్ బాల్, దీన్ని ఏమని చూద్దాం, ఓపెన్ బాల్ సెంటర్, ఏది సెంటర్ ఇక్కడ P, సెంటర్డ్
radius
ఎట్
P.
P విత్ రేడియస్ R.
R.
సో రెండు నొటేషన్ సేమే, బట్ రూడింగ్ లో డిఫరెంట్ వాడతాడు. రెండు నొటేషన్, రెండు ఐడియాస్, రెండు ఆర్గ్యుమెంట్స్ అన్ని సేమే. రైట్, సో దిస్ ఇస్ వాట్ యాక్చువల్లీ డెఫినేషన్. లెట్ us give an example. Suppose you take this x equals to R. My point is, suppose I'm going to take A equals to suppose 2, P equals to 0.2. My radius is equals to 0.1. So the neighborhood of P, that means what? This is my real line, because we are working with real numbers. What is the metric? Nothing is given means what? My metric is mod of x minus 1. My point is P equals to 2. My radius is this. So neighborhood of a point P with radius R is definition is set of all points in a real line, because my real numbers whose distance from x to P is nothing but what? Is less than R. But set of all real numbers, what is the definition? Distance between x and P, mod of x minus P is less than R. That is exactly set of all real numbers. When you solve this, what you get? P minus R less than x less than P plus R. That means what? Set of all real numbers lying between P minus R to P plus R. That means what? P minus R to P plus R. Therefore, what is your P? P is nothing but 2. R is nothing but 0.1. Therefore, 2 minus 0.1, 2 plus 0.1. Therefore, this is exactly nothing but 1.9.
1.9. 2.1.
Exactly, this is 1.9. This is 2.1. So set of all real numbers lying between this. So that means what you observe in general. So what you observe is neighborhood of a P with radius R in R is exactly what bounded interval P minus R to P plus R. It's a bounded open interval. Understand? In a real line R, any neighborhood is always bounded because that is what is the lower bound? P minus R. What is the upper bound? P plus R. So neighborhood is here actually bounded in R. What I'm saying? In R. Right? This is about neighborhood of a point with radius R. So suppose I'm going to take x equals to R. Suppose my metric is discrete. Suppose my point is same 0.2, my R is 0.1. What is neighborhood of point B with radius R? Definition is set of all points in a real line in such a way that whose distance from x to P is less than R. That means set of all real numbers whose distance, see what is R here? R is 0.1. So distance either 0 or 1 by discrete metric by definition. So here 0 or 1. So here 1 is not possible. This is not possible because whenever it is 1 less than 0.1 is absolutely wrong. Yes or no? Therefore, distance must be 0. So distance is 0 if and only if the only point which satisfies the inequality is center P only. Distance between x and P is 0 if and only if x equals to P because it is symmetric. Therefore, the set of all real numbers which satisfies this inequality is only P. That means what? Singleton P. So neighborhood of P with radius 0.1 is always P. Right? With the same, I'm going to extend. With the same point P, I'm going to take suppose 1. What is the neighborhood of a P? With the center neighborhood of P with radius R is exactly set of all real numbers such that whose distance from x to P is less than R. R means 1. Again, it is 0 or 1. 1 cannot be possible because 1 cannot be less than 1. The only thing is distance between x and P is 0. That means x equals to P. That means your neighborhood is only singleton P. Here, this is also bounded set because singleton set is always bounded set. Suppose the same center, my radius is 2. Or else you can take 3/2. Right? What is the neighborhood of P? Means set of all real numbers whose distance from x to P is less than 3/2. Again, here 0 or 1. 1 cannot be 1 always possible here. 1 possible. 1 less than 3/2 also possible. See what does mean by this? Here there are two possibilities. One possible as well as one possible and distance between x comma y is equals to 1 possible of course 0 possible 1 possible and if only if x not equals to P. Ante P కాని points అని satisfy చేస్తాయి. Distance between x and P 0 ఏంటంటే x equals to P satisfy. అంటే P కాని point satisfy చేస్తుంది, P అయ్యే point satisfy చేస్తుంది. Therefore what? Set of all real numbers అన్ని satisfy చేస్తాయి. P satisfy చేస్తుంది, P కాని point satisfy చేస్తుంది కాబట్టి total real line. అర్థమైనా? Distance between x and 0 P x, P 0 తీసుకుంటే ఓన్లీ P satisfy చేస్తుంది. Distance between x and P 1 తీసుకుంటే that means what? Distance is non-zero. Non-zero అంటే by definition x not equals to P. P అయ్యే పాయింట్ సాటిస్ఫై చేస్తే P కాని పాయింట్ సాటిస్ఫై చేస్తుంది. Therefore యూనియన్ ఏం చేస్తే ఏమొస్తుంది? టోటల్ యూనియన్ చేస్తే ఏమొస్తుంది? R వస్తుంది. Therefore neighborhood of a P point P with radius 3/2 is always R. Right? This is about neighborhood of a point. We can extend this idea. For example, suppose R2 ఇది యూస్ఫుల్ అయితే ఎక్కువ యూజ్ under root of x1 minus y1 whole square plus x2 minus y2 whole square. Okay, first one, suppose my P is 0 0, my R is 1. What is neighborhood? Neighborhood of a point P with radius R is exactly set of all points, the points which are nothing but what? Order pairs, because we are working with R2. So distance between x P comma x comma y, what is P here? 0 0. X comma y is less than R. But what is the distance? Euclidean distance. Under root of x minus 0 whole square, y minus 0 whole square less than 1. That is exactly x square plus y square less than 1. Therefore, what? This is nothing but what? The neighborhood of 0 is exactly what? Interior of the circle. Center at 0 with radius 1. Interior of the circle. X square plus y square less than 1 means what? Interior of the circle. This is nothing but what? Neighborhood of 0. Neighborhood of 0, 0 with radius 1. That means what? It's also bounded set. Right? It's also bounded set. Suppose you take this is D1. This is D1. This first example. This is my first example. Suppose my D2 you've seen this type of matrix today. So what is suppose my center is 0, 0 with radius same r. What is neighborhood? Neighborhood of P with radius r is exactly set of all points in R2 such that whose distance from 0, 0 is less than r. But what is my xy? What is meant by this? X comma y set of all order pairs such that x mod of x minus 0 mod of y minus 0 less than 1. Remains set of all order pairs such that mod x plus mod y is less than 1. అంటే ఏమొస్తుంది ఇక్కడ mod x plus mod y less than 1 అంటే ఏంటి? x positive y positive అయితే ఏమైతే x positive y positive అంటే ఏంటి? x plus y less than 1. x plus y less than 1 అంటే towards origin. In fact, it is dotted lines. This region. Next x positive, x negative, y positive అంటే ఏమొస్తుంది? ఇది x positive, y negative. This is x plus y less than 1. X positive, y negative. This is minus y. X positive, y negative అంటే y negative అంటే ఏంది? Mod of minus y is equals to minus y. So towards origin ఇది కూడా కదా ఇది. నెక్స్ట్ ఏంటి? x నెగిటివ్ y నెగిటివ్. x నెగిటివ్ y నెగిటివ్ అంటే ఇది మైనస్ x మైనస్ y లెస్ దెన్ 1. ఇది కూడా టువర్డ్స్ ఆరిజిన్. ఆరిజిన్ సాటిస్ఫై చేస్తుంది. నెక్స్ట్ x నెగిటివ్ x పాజిటివ్ y నెగిటివ్. x పాజిటివ్ y నెగిటివ్. ఇది కూడా టువర్డ్స్ ఆరిజిన్. సో వాట్ ఈస్ ద నైబర్హుడ్? Open rhombus. Open rhombus centered 0, 0. Right? But actually neighborhood of a point. Okay. It's okay. So with this I conclude today's class. Any doubts?
Yeah. Any question from your